So, good evening to all OFCM G4 2022 G4 participants, as well as people who are watching in YouTube streaming videos. So, warm welcome for this evening. I hope all of you would have enjoyed your Deepavali very well, and some of you may be celebrating also today. Yeah. So, today I have some small, there is going to be a lot of intervention for me. So, I will be here and there, I will be coming and going back. But anyway, Bala, Divya are there to assist. So, that's not going to be a problem. So, see, the thing is, first, what you have to do is look at the last statement, as Divya said now, last example statement in the last transcript, okay, last lecture, okay, and do it first in the discussion hour. We are not going to do it now. Do it first in the discussion hour. I hope all of you can do. So I have written it. So what is the last statement? I would just recall without writing. It goes something like this, right? In every state, in India, in every state, there is a city in which, given any street, by the by, given any, for every, both are same, okay? Given any street, there is a house in which every member has got PhD in mathematics. And did I use and or? That's where I have thing. Okay, anyway, you look at this.
And economics.
And economics. Fantastic. Accordingly, you should negate, and you should be ready with all those things. Symbolic form translation, and then finally writing in plain English. Do it first in the discussion hour. So today we will start with a new statement. Okay. Let me take a statement. Every 50, let's take 59. 59-headed human being has 23 legs. Okay. Every 59-headed human being has 23 legs. So, have you understood this statement? Quick. I want quick response. How many of you have understood? I'm not asking any question. Have you understood the statement? Good. Still, I need some more, but today, yeah, 63. That's good. Okay. Now, I'm clearing all the feedback. All of you know, can you think of the negation? Quick. This is just revision. So this we have done long back itself, but negation. Quick. See, while doing negation, think all those things also. What is the quantifier? If the statement has a quantifier, how many quantifiers? If so, identify the underlying set for all the quantifiers. All these things we should do in mind. But anyway, now I just want simple, plain English negation. That's all. 30 seconds. It's going to be over now. See, only 30. Yeah, somebody from R9. Is that Gubendran?
There exists 59-headed human being who doesn't have 23 legs.
Excellent. Okay. I'm not going to write. You do it during the discussion hour. One of our friends said, okay, what is it? There is a 59-headed human being. Okay. With some property. Okay. That you know, who does not have 23 legs. Right. Now, okay. I'll just even put on the negation. Okay. Don't look at the negation now. Okay. I'll just simply rub it out. All of you know the negation. Now look at the statement. My question is this. Is the statement true or false? Quick. What is my question? We have already answered negation. If the statement is true, say yes. Put a tick mark. If the statement is false, put no. Please think and answer. Very good. Response wise, it's okay. Still, we need people to answer. Very good. So, brutal majority. Okay. Nothing to talk about. There is only one person who is saying the statement is true. If it is yes, then it is true. Only one person is saying true. 47 of you so far now have said it is false. Correct? Right. Let's go to that student and ask. Who is that? Can mentor, can you find out who is that?
Abhinaya.
Abhinaya from R3. Yes. Abhinaya, quick.
We cannot prove that statement is false because we cannot find the person with 59 head. So we cannot say that the statement is false.
Can you explain further? You have some logic, but still it has to be. Okay. Can you again explain why this statement is true?
Because we cannot find a 59-headed human being.
Exactly. Do all of you understand her? I'm clearing all the feedback. See, what does she say? The statement is true because I cannot find a 59-headed human being. Okay, I'm clearing all the feedback. Please, all of you think now. Okay. See, do it like a challenge. You know, I'm saying every 59-headed wait. Please wait. I will explain. Then you can ask for doubts. See, the statement is every 59-headed human being has 23 legs. Okay. True or false? Sir, how we should answer? I don't know. So somebody is telling true, somebody is telling false. Okay. So let's stand. Let's argue for the person who is saying it true. Let's try to argue. Okay. The person says every 59-headed human being has 23 legs. Okay. Okay. How will we argue? So what if he wants to prove what he has to do? If at all there is a 59-headed human being, he has to show 23 legs. So he will simply say to us, yes, sir, show 59-headed human being. I will show you 23 legs. Is the point clear? Yes or no? This is where you have to think. If you have understood this point, you can respond now. Now the person who asked doubt can also call. Okay. If you have doubt, you can raise your hand. Still think about this. That's what our answer is. I can't find a 59-headed human being. Therefore, the statement is true. Okay. Let's look at the statement carefully now. Very good. Very good. I'm clearing all the feedback. Still, a lot of people have to understand. Good. Let's look at this statement carefully. Okay. What is the underlying set here? Can one of you say quick? I'm going to ask one of you randomly. Let's ask from R1. R1, Jayashree. What is the underlying set for the quantifier every?
59-headed human being.
Excellent. So let's have S to be 59-headed. Okay. S is the set of all X in H such that X has 59 heads. Okay. What is H? H is set of human beings. Correct? Okay, good. So now let's rewrite the statement. What is the rewritten statement? For every X in S, what is the property X has? Can Jayashree say again? What is the property now?
X has 59 heads.
Very good. No, that we have already collected. X has 59 heads. For every X in S, what is the property we are saying? Look at the statement.
X has 23 legs.
Very good. It has 23 legs. If the statement is false, then what is the negation? All of you said already. There exists X in S such that X does not have 23 legs. Okay. Now the question is, which is true, whether the statement or the negation? Now look at the negation. The negation promises a 59-headed human being with some property. Forget about this property. It says I can find a 59-headed human being. That's problem. Okay. Therefore, the negation has to be false. Negation is false. Therefore, original statement is true. Please go through. Bala can continue for some time, right?
Okay, sir.
Otherwise, okay, yeah. I'll be here, but I'll be muted, right?
Okay, sir. Then you have to stop sharing, sir. So we shall proceed from here. Is it visible, Ms. Divya?
Yes, sir. Yes, sir. It's visible, sir.
Oh, wait a second. Let me check the participant. Able to the participant. Wait a second. Maybe then you can call the people here.
Yes, sir. Then I'll call.
Yeah,
sir.
I have started from the browser.
Yes, yes.
Okay. So students, we shall start from here. First, we shall look at in this statement as well as in all the statements we have seen so far. We were concentrating in identifying the quantifiers and the underlying set. Then we have concentrated on the properties, the property which we were talking about. So here, look at the set. What letter we have used? Yes. X belongs to capital H, such that X is having 59 heads. That is the underlying set. One of you correctly mentioned. Now, from now onwards, we shall concentrate on studying about the sets, how to write them, and how to identify the sets, or how to describe them properly. So first, let us define how a set should be. So let us write a set as a collection of objects. Have you studied some set already? The objects may be numbers or functions or sets or any other things which we define. Oh, sorry that I am unable to look at your response. Wait a second. One yes. That's okay. Let us first start with the set definition. A set is a collection of elements sharing a common property. This we shall fix. collection of elements sharing a common property. The elements may be numbers. The elements may be functions. The elements may be any other objects, or we need to consider the common property. So can you give some example of sets which you have seen already? Say yes or no. Collection of elements we need. You know what is element? Soumya, tell me some set.
Set
We
of
want
integers.
to talk about how it is. Set of integers. Okay, let us start from that. Set of integers. I want to write that set of integers. How should I write? Usually I write capital letter denoting the set. I'll be writing this notation we use for set of integers. Okay. And any other set? Any set? See, I want to write down how many set of these. Malati, how many elements are there? Usually we study. Yes. Usually we
Sir,
study
your
numbers.
voice is breaking, sir. I think,
Sir.
Voice is breaking.
yes, sir.
Right,
Sometime.
Okay, please stop me if it is continuing. Okay.
Yes, yes, sir. Yes.
Thank you. So let us start with this set of integers. I want to write it, the elements. I want to write the elements of the set. How do I write it? We consider set of real numbers. A set of real numbers. Of real numbers. Sets we can use. I want to describe proper. For example, write down the set of integers, okay, starting from 1, 2, 3, 4, 5 till 25. I want to write down. How do I write it? I am just writing code subset from here. That also I need to define. Just I want to write down the integers starting from 1 till 25. So I write that. Maybe I have to clear it back. Then you may reply. Some of you, if you know that, then we shall proceed. I want to write down. Are you understanding the question? I want to write not the entire list. The entire list is difficult. You see that I am unable to write the entire list. Maybe we will do it soon. First, I want to write down positive integers starting from 1 till 25. How should I write it?
I'll share.
Yes.
Yeah.
Just, sir, we just defined the set. That's all.
I was there. Right.
Okay, sir.
Okay, fine. So as Bala said, set is a collection of elements sharing a common property. That's the modern definition of sets. Okay. As Bala asked, you asked till 1 to 25, right?
Yes, sir. They said integers, set of integers. I want to write integers from 1 to 25.
Let's call that set as A. What is A? A is set of integers. I'm writing in plain English. From 1 to 25. This is plain way of writing, but that's not the mathematical way, right? So how do I write? One way I'll say, which all of you will think, right? This is the way. Okay, 1, 2, 3, then we'll put ... Okay, then 25, right? See, this is called listing, and we don't do it. This is bad listing, okay? Bad listing. List all the elements. See, sometimes it's allowed for understanding, you can do this, but this is bad listing. Okay, why? 25, okay, I can write, but let's think of, okay, a very big number, 2 lakhs. Even writing 2000 is very hard, right? So we don't write like this. We are going to list it in some other form. Okay. So that's why So now we will write in this form. A is what? Collection of integers. Okay. Therefore, I will simply put M in Z, okay, with some property. Collection of integers with some property. This is the property. Whatever I have written in the dash, I have to find out. Okay, that's what. So if M belongs to A, or in other words, if M belongs to A, what is the condition on M? That's what I'm going to put here. Okay, can all of you think of what is the condition? Quick. So you can even write M in Z such that M is consecutive integers starting from 1 to 25. That will be again an English description. Okay. Now, how do I write this? Because I have collected integers, there is a better way of doing it. That's what you got to think. Okay, let's ask one of you now. Okay, you can ask now R7. Kalish.
Ishwari.
So for all M belongs to Z.
No quantifier. Why? There is no quantifier in this statement. If M is in A, what is the condition? See, look at the second dash for me.
So 1 less than or equal to M, less than or equal to 25.
Excellent. There are two conditions. Don't say like that. How many conditions are there?
2 conditions, sir.
What are the conditions now you tell? M is
Less than or equal to
25.
25.
And
And M is greater than or equal to
1.
1.
Very good. M is an integer. Okay, then this is the property we have to. But there is, we don't write usually like this. We club and write. Okay, how do we write? 1 less than or equal to M and M is less than or equal
to 25.
That also we understand. Okay, then the next step is 1 less than or equal to M less than or equal to 25. But this is a notation. We have to understand there are two conditions. Correct? If we write like this, all of us know there are two conditions. Okay. So one can write in any manner you like, but the best way is, so therefore, we'll write here. We don't go and write there. How do I describe my set? Collection of all integers with some property. What is the property? 1 less than or equal to M. In fact, I can write like this also. And M less than or equal to 25. That doesn't matter. If you want shorthand notation, that also you write. 1 less than or equal to M less than or equal to 25. That's also allowed. This is also allowed. Very good. So I'll clear all the feedback. Okay. Let's now do like this. Okay. Now let's collect all the real numbers between. Okay. Let's say all the real numbers between 0 or let's collect all the real numbers between A and B. I don't know what A is, what B is. But all I know is A is less than B from the pictures. Okay. Collect all the real numbers between A and B. So here the question is vague. Between A and B, do you include A? Do you include B? All this question. Okay. So I will simply say strictly in between. Strictly in between A. Okay. Can you think of the condition? So how do I write that set? Collect all and call that set as B. Okay. How do I write that set B? Think, all of you should think. Now, today, why response is very slow? If one of you have unmuted, better to mute. That's right. So somebody from R3, R2 rather, R2.
Jayashree, sorry.
Uh,
Dhanraj Prasanna.
Dhanraj. But why today? What happened? Why slow response? Yeah, Dhanraj Prasanna, say.
X less than A, then X lies between A and B.
How do I write that? That's what I question. You are also saying the same thing. See, I don't know how to write B, right? If X is in B, what is the condition on X? How many conditions do I have?
X greater than A and
What are
X
the
greater
right.
X greater than A and less than B.
Very good. X greater than A and X less
X
than.
less than B.
So we'll write this set now. Now, okay, we know what is the condition. Okay, X in B by definition means X greater than A and X less than. X greater than A and X less than B means X in B. So now how do I write this set B? B equal to, this is what is called a roster form or set builder form. People will say no. So now I'm clearing all the feedback. One of you should be ready to say, how do I write the set B? Now we have understood what is the condition. Take an element of B and what is the condition on that. What are the conditions? Okay, now you should tell me how should I write this set. Quick. I'm asking very easy question. Stay focused, you'll be able to answer. I could hear some sound, right?
Yes, sir.
Yes, sir.
We
Fan sound or something.
find out, you can mute also because it could happen. Then mobile connection is poor also. But I see response is very slow. R9, Akhilandeshwari, Satya Bala, Akshara. What happened to you people? Okay, now R9, Akhilandeshwari. Quick.
X belongs to R.
Set of all X belong. No quantifier here, no for all and all. Collection, right? X belong to R with condition, right?
Such that A less than X less than B.
There we go. A less than X less
Less
than.
than
I'll write in your favorite form, but please understand this means it has two conditions, X greater than A and X less than B. Even if I write this two, that's fine. Okay. How it is denoted? Akhilandeshwari, do you know? Have you seen so far? This B has a special notation. The notation for B is, it depends also, it changes from people to people, but we follow this usually. Open interval A comma B. Okay. So what is the definition of open interval A comma B? That's this. Collection all X in R such that A less than X less than B. I am clearing the feedback. Okay. Now let's try to write this set. Okay. Close DA, open D. Quick. All of you think, say it in the final form. Still, lot of people. Okay. R4 Punlakshmi.
Sir, A less than or equal to
No,
X.
you have to say the set correctly. That's all. See, already we have written here, right? Follow. Again, don't say, explain and all. Directly say what the set is. How do I write it in set builder form? That's what you got to say.
Set of X belong to R.
Very good.
A less than or equal to X less than B.
You understand? So how many total conditions are there? X greater than or equal to A, one condition, A and X less than B. In X greater than or equal to A, there are two conditions, X greater than A or X equal to A. I think all of you know that, right? Fine, fantastic. Very good, Purna Lakshmi. Okay, now let me write this. Minus infinity, comma, D. Just understand. Okay. I'm clearing all your feedback. Quick. See, I'm putting a trap. Don't fall in the trap. Be careful. Understand properly. Okay. But I want your response. 30 seconds time. Still 30. Only 30. This is easy. What happened to R6? Radhika, Deepika, Subika, R6 again. Sultana. Couldn't see your responses. Okay. Jasmine Jennifer from R3. Can you answer? Jennifer? Jasmine
Yes, sir.
Jennifer?
Yes, sir. X belongs to R.
Set of X belongs to R.
Yes, sir.
Right. With what property?
Minus infinity
Okay, I'm writing it. But let's see. Minus infinity.
less than X
Hmm.
less than B.
I said I will put a trap. Okay. It's something like what people in zoo drew, right? They want to catch an elephant, they will dig a hole. Okay. Put lot of bushes on that. So elephant will fall. So you have also done like that. Okay. So all of you think, should I correct this? How to correct this? There is some problem. What is the problem? Identify and correct. Quick, those who know how to write it properly can now, I have cleared all the feedback. Quickly say. So others, I'll simply mean that this is right for you. If you know the correction, see all the 14 of you are saying, I can correct, right? Okay, let's ask R8 Aswini.
Sir, can it be X less than B?
Why? That you have to explain. Don't ask me. You have to say it confidently.
Yes, sir.
There is
X less
only
than
one
B.
condition, right?
Yes, sir.
Right. This is purely notation. Okay. Actually, there is only one condition. X less than B. I should write like this one. Okay. That's what I got to ask. When I want to describe this, what is the condition on X? Okay. The condition is simple. There is only one condition, X less than B. Okay. So B is here. Think of the real line. And what are all the elements which will come? All the elements left to the left of D. D is not allowed. All the elements to the left of D is allowed. Do you understand? No more conditions. See, infinity is not at all a real name. It's a notation again. What notation? Notations are like traffic signal. Okay. What we will do if we see red color, we will stop in the middle of the road, right? And if it is yellow, we'll be ready. Green, we go. Suppose we go to, say, some marriage hall, and if we see red color, will we stop at the place? No, right? So there we don't have that notation or the symbol. Okay. See, the traffic signal is only meant for traffic thing, right? So don't take infinity to be an entity and compare. Okay, we are not working on any real number system now. It's pure notation. It's not extended or something like that. Nothing. So this is a notation to say all the left. In fact, people would have put any notation, whatever you like. Okay. something like star, bushes to be like this, they would have done. Here, what will I do? Another notation they could have done. Okay, it's simply a notation. Okay, to check whether you have understood, I'm going to ask this question. What is a comma infinity? Okay, closed a comma infinity. Quick, one of you should answer. But I want all of you 30 seconds time respond. No. I will clear the feedback. Now you start. Because I have cleared the feedback, again you respond. Very good. R5. R5, Darshini.
Sir, set of x belongs to R such that
Very good.
x less than or equal to A.
Very good. That's the only condition. X less than or equal to A? Say it correctly. So, well, think geometrically, no, maybe the inequality you are not getting correct. Let me ask this question. Suppose if I draw A here, which elements should come? Quick. Darshini, quick. To the right of A or to the left of A? Quick, Darshini.
Sir,
Which element should come in the picture?
sir, x greater than or equal to A.
Okay, don't worry. See, the thing is, you should not get offended. You say right of A, then you can write the symbol. Okay, to the right of A. If the right of A, if I pick an X, what is the comparison? X is greater than E. So, A is also allowed. So, X greater than or equal to E. I hope all of you understood, right? Go back to discussion hour. Okay. Discuss lot of questions. What it means to say X does not belong to open interval. See, this is discussion hour question. Do other examples also. Okay, like this. Okay. Now let's go with. Okay. Now what I want to do is I want to write even integers. Okay. In fact, I'll write even natural numbers. E for me is even natural numbers. I want to describe this as a set. Okay. What is the bad way? Bad way of writing is just putting even natural numbers. 2, 4, 6, 8, ... Dot, 3 dots and comma. People even say and so on, right? Something like that. But this is a bad way. But now can you do a listing form? See, before writing listing form, okay, what I have to do? I'll take a natural number. N belongs to E. If N is in E, then what is the property? What is the condition on E? Condition. Okay. What is the property? What does N have? Okay. If N is an even natural number, what can I say about it? That's my question. Yeah. Responses, please. If N is a even, N belongs to E means N has to be an even natural number. Okay. For me, E, I have said that it is a set of even natural numbers. Set of even natural numbers. Oh, 2 times I have written natural. Okay. Set of even natural numbers. So bad way of describing is listing all of them. We don't do it. Okay. So I have put a cross mark. Don't think that it's correct. Okay. This is a bad way. Let's do better nesting. Better listing. Okay. As we have done before. For that, I want to look at what is the property. Okay. N belongs to E. Okay. I want to see whether some of you can tell. Quick. Only 22 responses. Let me go. R5, Sophia.
2n, sir.
But you have to say correctly. Say correctly. 2m what? I don't understand. No, explain. N. I'm helping you.
N belongs to E.
Means, okay, then
N belongs to natural number.
that is there. Very good. And n equal to, you said something.
N is equal to
Ah,
2m.
very good. N equal to 2m for some m. Okay, for some natural number m.
Yep.
Right? This is quite natural. Very good. Okay. See, look at all the numbers. If I take 8, 2 into 4 it is. If I take 12, it is going to be 2 into 6. If I take 500, all of you know what it is going to be, right? 2 into 250. Okay. So how do I list now? Now I'm clearing all your feedback. I want only listing form. So how do I list now? E equal to, maybe as a first exercise I will do. How do I list? I'll simply write 2m. Yeah, one of you is ready. I'll simply ask. Okay, again Sophia. Okay, who said that? Angeline, R6 Angeline, quick.
Sir, E is equal to 2m such that m belongs to capital M.
Very good, excellent. I should have asked before. See. Okay, bad teacher, right? I should have asked. Already I should have got it to some people. This is called a listing form. See, the listing form will not say which is subset and all. I have to find out. M is a natural number, therefore twice M is also. Therefore, I have to say E is a subset of natural. That I will understand. I won't say anything. But it lists all the elements. It generates how? I will put M equal to 1, then I will get 2. If I put M equal to 2, I will get 4. If I put M equal to 3, I will get 6. Okay, this is listing form. Better way. Same thing, we have not done anything different, but this is better way of listing. I'm clearing all the feedback. 20 seconds response time. Say whether you have understood the listing form. Quick. Great, good. So let's now do official form. There is one more form called official form. Okay. Listing form, when we give examples or when we want to understand things, this will come. Okay. Official form will be used in proofs. You'll come to know why it is called official. Okay. In MTTS, we have a special name. We call it. Okay. Now, let's, okay. In official form, how I'm going to write? I'm going to first describe this as a subset of. So I will simply write X is a natural, as I said before, element sharing a common property. That means what? X is a natural number with some property. This I have to write properly, what property it is. Okay. Already we have found out n equal to 2m for some natural number m. Okay. First, so let's again do it here. If x is a even natural number, then what we know? X is of the form 2m, right? For some m in z. Okay. M in n for some natural number m. Or even I could say n in n, whatever I want, I can say. Right. Excellent. But now think about this statement. I want to make it very clear. I can even write this property x equal to 2m for some in m in n. Okay. But I want to be much more precise. Okay. Let's look at this statement. If x in E, then I have listed some property. Think about this property, whatever I have underlined. Does this statement have any quantifier? If so, what? And okay, quick. That's my question. Whatever thing I have underlined, x equal to 2m for some m in n. Does this have any quantifier at all? If so, what quantifier? Just only this part. Do not worry about if x in E, then and all. X equal to 2m for some m in n. Does this part, whatever I'm putting in the box, does this have any quantifier? If so, quick. It should be quick now, actually. We are in the 6th session. Still, responses are coming slow and it is very okay. Let's ask someone who has not answered. R6 Radhika.
Sir, for every
No. Think carefully. For some. For some. Okay. What is the correct quantifier? Okay, there are only two. If I said one is no, then the other should come. So that's, you have to really think. Can x be equal to 2m for every natural number m? X is only one number, no? Can it be equal to 2? 2 into 2? Can it be equal to 2 into 3? Can it be equal to 2 into 4? Okay, you are destroying the property of natural numbers, right? Can happen only for here, not for some m. It can happen only for exactly one m. Okay, that's a different issue. So what quantifier should come? All of you are clear now, right? Okay, write it as a correct statement. In your mind, I'm going to ask. I'm clearing the feedback. Now all of you know what the quantifier is. Write this as a proper statement. If x belongs to E, then I have to write it as proper statement in symbolic form. Quick, be ready. Why it takes this much of time? It's equal to 2m for some m. Okay, what does that? Some G4 participant has a poor network connectivity. That means what? Whether everyone has poor network connectivity, right? So which quantifier you know, right? Yeah, quick. See, still very few. Okay, R1. R1 Sivakumar.
If X belongs to E, then
Ah,
there exists some
very
M
good.
belongs to natural number.
Don't say some. There exists.
There exists M belongs to natural number.
With what property?
X is equal to 2M.
Very good. Okay, this is what I have to go back and write. So therefore, what is E? E is, see, first condition itself says it's a subset of natural numbers. In listing form and all, it will not be there. I have to identify. I simply, okay. So here I will simply say X belongs to N with this condition. With what property? There exists M in N such that X equal to 2M. Okay, I am clearing the feedback. Have you understood this second? Okay, official form, official way of writing. If you have a doubt, say no or put a question, hand raising symbol. I will come to know. But I want responses. See, to be it's very easy. To be an even natural number, it has to be of the form 2m. It has to be of the form 2m. What does it mean? What is the proper way of describing? Means x equal to m for some m in. How do I write that? The correct quantifier is there exists. Okay. So I have to write it as a statement. There exists m in n with what property? X equal to 2m. That's it. Very good. Okay. Now we will do something like coaching class. I want to make sure whether you have understood. Okay. So let's do odd integers. Okay. So O is set of odd integers for me. Two forms I want. Let's first do listing form. O equal to listing form. All of you be ready. Quick. First listing form. Concentrate. Just I have to write down listing form of odd integers, not odd natural numbers. Odd integers. I know what are odd integers, right? So how do I write it in listing form? Not like -1, not listing completely. Okay. -1, 1, then -3, 3, not like that. I'm not going to list like that. Okay. So proper listing form. We have done 2 already here. Not the bad way, but other listing form. This is the bad way. Right from the beginning, we are saying this. Yeah, please quick. Okay. Let's ask somebody from R8. R8, Krishnamurthy.
N belongs to integers.
Krishnamurthy, can you come again? Because we couldn't hear you properly.
2n plus 1
2m.
such that
Very good. Such that
m belongs to integers.
very good. Integers means z, right? Integers. Excellent. Okay, I'm clearing all the feedback. Is there any other way to write it? But why suddenly now 1 tick mark is coming? Is there any other way to write? Listing form. Same in listing form. Quick. Now the response should be fast. Very good. Ashwini says there is another way. Let's ask. All right, Ashwini.
Yes, sir.
Hmm.
It can be x belongs to integers. X belongs to integers.
No, that is official form. I'm not asking about official form.
Yes.
That's very good. Keep it with you. Don't say it now. I'm going to ask. Is there in the listing form itself? Can I write it in some other way?
Yes, sir. It can be 2m minus 1.
Very good. Very good. O equal to 2m minus 1 m minus 1. You start with m equal to 0, I'll get -1. If I put m equal to 1, I'll get 1. If I put m equal to 2, okay, I'm going to get 5. Same thing. I do all. You can now check. Okay. I'll get all the odd integers. Okay. Excellent. Now let's go for official. Okay. Clear the feedback and you'll be ready. So quick. So official form, do not worry. Half of them is already there. What is half of them? O equal to it. This is I'm going to collect all integers with some condition. Okay. So set of x in z is already there. I have to just now write only the condition. So all of you think what is the correct condition. Already you have said that also. So it should not be tough at all. That's why I said it's like coaching class. Okay. Something will be taught, and same kind of 5 questions will be done. Okay. That's okay. But the thing is, newer one, you should be ready. You should be ready to think. You should understand. That's my point. Okay, let's go to what is the batch I have not asked at all? R6. I think I have asked R6 also. R6, Rahul now. Rahul.
There exists m belongs to z such that x is equal to 2m plus 1 or 2m minus 1.
Anything, one thing you use. Shall I write 2m plus 1?
Sir, or plus or minus 1?
No, that's okay. Keep 1. No, why should I write plus or minus 1 now? Keep 1. If you want to write one more, you write 2m minus 1, right?
He needs both conditions at the same place. Either this or that.
That will imply both. Okay, we don't want that. Keep it only 1. If you want write 2m minus 1, again write another. Is it? Have you understood?
Yes, sir.
Rahul, that's what. Okay, don't put two things, otherwise it will come inside the set and it will disturb you. Understand? Very good. Excellent. So what is discussion? Our other questions, first finish this discussion. Our other questions are odd natural numbers. Okay. Other question, try to describe odd natural number, even integers. Okay. Just to see whether you understand. Now, what I am going to do is, now I am going to write down a set. Bala, I think you have to continue. Bala, can you continue?
Okay, sir.
I will stop sharing.
Sir, what should, okay. So let me share screen. Wait a second. Is it visible?
Yes, sir.
Okay. So as of now, we have discussed about what is a set and how to write it. While writing, we have three ways so far. Listing method, again listing method, which is somewhat better than listing all the elements. So we were looking at some property. Then finally, we have written official way of writing a set. So as Sir said, you can discuss how to describe set of add natural numbers in official form of writing. So you should collect natural numbers satisfying some common property. How to find it out. And in the recent example, in a set of wait a second. In the recent example, in set of add integers, someone of you was saying either x equal to 2m plus 1 or x equal to 2m minus 1. Any one of them is fine there. Any one condition will give you all the add integers. We just discussed that in the discussion room. We shall look at another example. We have discussed about integers, and we should look at rational numbers. How do I define rational numbers? Can we try to write down rational numbers in official form? That we shall go for that. Okay, I'm clear. Okay, you think about it, how a rational number looks like and how I should write it in official way. So if anyone is familiar with rational number definition, you can suggest me how to write it. Just I want to write down these numbers are rational numbers. I want to write down a set of rational numbers. Can you respond? So how do I describe rational numbers? Any of you know about that, or is there any response? Anyone is saying yes? 9
Yes, sir. 10.
students are saying yes.
Yes,
Okay.
sir. Yes, 10,
Just
11.
if you know rational number, just I want to write it down. How to write it? That's my question. That's what we need to discuss. Now I want official way of writing that. We shall wait for 2 seconds more. Okay. Let me ask R6, Angeline.
Sir, x belongs to
I want to write down, say, this name. Let me write down. This I want to write down as
x belongs to Q.
you should start with. Okay, let me write down. X belongs to
Q such that
This is what I want to write down. What kind of numbers are in set of rational numbers? How they look like?
Q,
Yes,
for some
proceed.
P by
P by Q form we
some-
need. Okay.
Yes, sir. For
What
some P
about P?
comma Q belongs to P comma Q belong to
For some P comma Q belongs to
Z.
Okay. Any other condition?
Such that Q not equal to 0 and Q not equal to 0.
And one more condition we are having, Q not equal to 0. We need, so these kind of numbers, if so you are suggesting if X is in this form. Okay.
Yes, sir.
Now I want to write this properly. How do I write it? So properly in the sense that I need quantifiers upfront and I write a conclusion. You remember the recent examples? We are having quantifiers upfront. So how do I write that first? How do I write it? So this is what I know already, just I want to write down properly. So my set, let me give this name. Okay. He is defined as. How should I write it? Maybe I'll clear the feedback. No, every information what we need is available with us. We need to write properly. Let me clear the feedback. So someone try for this and I'll call you. How do we write this properly? Do you see the screen? Is it visible? The screen.
Bala,
Yes, sir.
yeah, they have given some examples and some non-examples. Please ask them.
Sorry, examples are
some rational numbers, some which are not rational numbers. Just some examples, ask them.
Okay, sir. So let me clear the feedback. Someone of you. Okay, well. So those who know about rational numbers, you can give some examples. Examples for rational numbers. Raise your hand. I'll say yes. I'll call you. Give me some examples for rational numbers. Then we will describe the set.
Yeah, R9 Sattavala. R9 Sattavala.
Satyabala, are you there?
Somika 44. Somika.
Sir, yes, sir.
Okay. So give two rational numbers. That's some example of rational numbers. I want.
So 5 by 9.
5 by 9. Another.
2 by 3.
Give one which is not a rational number. Something, a number which is not a rational number.
√2.
√2. Another.
√3.
Yes. √3. One more.
√5, sir.
√5. What about pi? Okay. So we have some numbers which are
Sir,
not
not
rational.
pi, sir. √5.
No, I said pi.
Okay.
Pi, no, I mean this ratio between circumference and this.
Look at the screen. We have written that pi, pi.
Now question is, now you see, I mean, you are giving examples of numbers. Some are rational numbers, some are not rational numbers. Okay. When you are giving these numbers, where from you are giving? All these numbers you are talking about, these are all real numbers, right? So in the set of real numbers, you are giving me some examples. Some are rational numbers, some are not rational numbers. Why √2 is not a rational number? Because root 2 you cannot write it as P by Q, where P and Q are integers, right? So that means we are talking about numbers coming from real numbers. Some real numbers are rational, some real numbers are not rational. So when I'm defining, I will say that those real numbers X, which are of the form P by Q, these are my rational numbers. Can we clear all of them? I mean, clear the responses? Okay, no, it's fine, yeah. So the statement is what I'm saying, that rational numbers, what are rational numbers? Those real numbers which can be written as P by Q for some P and Q integers with Q non-zero. If you agree, click yes. I repeat, because you are saying that a number which can be written by P by Q, that means there are also numbers which are not, which cannot be written this. So some numbers can be, some numbers cannot be, but where from we are bringing? We are bringing from the set of real numbers. That's right. Yeah, please continue.
So we shall, let me clear the feedback. So the property we have mentioned here, now can we write it in the official way? Those who can say, you can click yes. So the property which we need is on the screen. Already one of you mentioned.
Yeah, Bala, when we write, then only they will realize that actually.
Okay,
Just
sir.
write it and go ahead.
So, sir, already we have done this add integers, even natural numbers. So we shall collect the set of all real numbers satisfying some number. What kind of real numbers already you have mentioned? So can one of you suggest further, Devashree? What should I write next?
Exist P and Q belongs to Z.
There exists P and Q.
P and Q belongs to Z.
Okay.
And P and Q not equal to 0.
And Q not equal to 0. Maybe I'll write with Q not equal to 0.
Such that X.
With what property?
X
That
is
bracket
equal
I'll
to
use
P
for
by,
such that X equal
X is
to.
equal to P by Q.
So this is, I'm collecting elements from.
Bala, I'm back.
Okay, sir.
Yeah,
Just we
you
have,
can continue.
just we have written. We have initially we asked what kind of numbers are rational
Very
numbers.
good. Excellent.
Now, sir asked some few examples they have given, and also they have mentioned the property also. Now I am collecting real numbers satisfying this property.
Yeah.
So in the property we are having quantifiers here for some that we have written as usual. Upfront we write the quantifiers. There exist P and Q integers with Q not 0, where X equal to P divided by Q. Only this property is satisfied that real numbers are called as rational numbers.
Okay.
Maybe, sir, you can share, sir. Then.
Yeah, fine. I'll share.
Yes, sir.
I'll continue. So, having said that, now I'm going to write one more set, identify what this set is. Okay. Let me use notation A. A is what? Now for me, set of real numbers X with property. What is the property? There exists A comma B ordered pair in Z cross N. Okay. Such that X equal to A by B. Okay. So have you understood? This is the way which we said in the last class, right? And writing the underlying set carefully. So where does A come from? A is set of integers. Where does B come from? Set of natural numbers. Okay, right. With the property X equal to A by B. Now what is the question? Find A. Identify the set A. Identify in the meaning that already there is a set which is, no, find out what A is. It will turn out to be a known set for you. Okay, that's the meaning of identifying. So that's what we say. Can you find A? Okay, so I'll clear all the feedback. So now what I'm trying to say, there exists a integer A and a natural number B such that X equal to A by B. Okay, I hope all of you have understood this. So now what should be the set A? See, it's very simple, easy question. If you stay focused, you will be able to answer. Yeah. So extended 30 minutes. So totally 1 minute time for this question. Just say the answer. We don't want any proof. A is this set, sir. That's all. I don't want any proofs. Yeah, so extended time is over, but still we could get only less. Anyway, let's ask somebody from R5. R5. Now no one. Kavipriya, Shweta, Safia, Lekha Shri, Dirgadarshini is ready. Lakshmi is also not ready. I don't know what's happening to your group. Yeah, Dirgadarshini.
Rational number.
That's all. A is set of rational numbers. Anybody says a different answer? See, that's all. See, don't require. Can you identify? That's the thing. There could be a lot of reasons. We'll bring out that later. Okay. Do you have any other set? You think rational numbers is wrong? If it is right, put tick mark, no, quick. If it is wrong, put wrong. This is a question. See, I purposely asked because I want to see the participation. You should understand. Okay. Good. So, we found out A is Q, right? Very good. See. Now, I want to prove this. Okay, right. Still question mark remains. Only if we prove, we will come to know, right? Verification part is always there. Identifying part is different and verification, proof is verification part, right? I have to prove, right? Okay. So when do I say to, what should stay focused and answer this question? Okay. If I want to prove two sets are equal, already we have seen. What are the things to be proved? Can you say? Quick. Now, very quick answer. Yeah, let me ask Malati. Quick. Malati. Very good, Malati. Very good. See, that's what immediately you should answer. It's a quick response. You should say, A is a subset of Q and Q is a subset of A. That's what I have to prove. Okay. So which is easier? A is a subset of Q is easier. Why? Start an element. Again, I have to prove. Now I'm going to give a oral proof. Look at this. Start X in A. I'm not going to write. Okay. Then I know there exists AB in Z cross N such that X equal to A by B. What is A? A is an integer. What is B? B is a natural number. Therefore, B is an integer. See, I want to say X in Q. Therefore, I should say it is of the form P by Q, where P and Q are natural numbers. Sorry, where P is an integer and Q is also an integer with non-zero integer. That's what I have to say. Just I have to really say, A and B are integers. I'm happy because every natural number is an integer. Is that correct? Every natural number is an integer. Okay, right. Only thing is whether B is 0 or not. So B is a natural number, therefore it cannot be 0. Therefore, A and B are integers with B not equal to 0. Therefore, it belongs to Q. Have you understood the forward part? Quick, I think we are nearing the time. Anyway, Bala, I'll take just 3 minutes extra.
Okay, sir. Okay.
Yeah. Quick, your response. Have you understood the proof of A subset of Q? If no, say promptly no, because I may be rushing, you may not be understanding. So do not worry. If you don't understand, again ask. Start with X in A. Then by very definition of A, there exists A, B in Z cross N such that X equal to A by B. Now, A is already an integer. B is a natural number. Therefore, it's an integer. So A and B are integers. Do I know that B not equal to 0? Yes, because B is a natural number. Therefore, it is not equal to 0. Therefore, X is of the form P by Q. T is A, Q is B. And both P and Q are integers with Q not equal to 0. Therefore, by very definition of rational numbers, X belongs to rational number. So Q. Therefore, X is a rational number. Therefore, X belongs to Q. Therefore, A is a subset of Q. Okay, right. Now, let's try to do the other way around. Is Q subset of A? Yes. So, I'll start with the X in Q. Then what do I know? Then I know there exists P comma Q in Z with the Q not equal to 0 such that X equal to P by Q. Okay. Now I want to say X is of this form, right? I want to prove X, we have to prove, right? We have to prove X in A. Okay. This is what. Let me start with the arbitrary element X in Q. We have to prove X in A. So for that, I have to say what is my A and what is my B. Okay. Let's not rush. Let's take some examples and see. Okay. Suppose X is 2 by 3. Can all of you say, I have to choose A, right? I have to say A is this, B is this, with B being a natural number, A integer. Can you say what is A and what is B for this choice? Quick. I want quick responses. Yeah, good. Still more. Still, I want people to respond. It's very easy question. Yeah, now R5 Kavi Priya.
X A is equal to 2, B is equal to 3, sir.
Very good. Okay. So what happens if X is minus 4 by 5? I'm clearing the feedback. Okay, let me keep the same feedback. Doesn't matter. Now somebody from R8. Who is R8? Saranya, quick.
A equal to minus 4, B equal to 5.
Very good. Okay, all right. What happens if X is 4 by minus 5? Saranya, you can answer quick. All of you think?
Sir, it not defined, sir, because
No, see, integer could be of this form. No, I have started with PQ in Z with Q not equal to 0. That's all. It's defined pakka. It could be Q is a negative integer. It could happen, right?
Yes, sir.
So think carefully. Yeah. Somebody is ready with the answer. Who is it? Yeah.
Rahul.
Okay. All right, Krishnamurthy, quick. Or Rahul. Somebody should answer. Rahul, yes.
So A equal to 4 and B equal to -5.
That's not allowed, no. See, that's what you are not understanding. B should be a natural number. If you take A equal to 4 and B equal to -5, then it is wrong. I can't do that.
Sir, -4 by 5 or 4 by -5 both mean the same. So A can be -4, B can
Very
be.
good. Yeah, I got to change it. A is -4 and B is 5. That's very good. Okay. But this is not the proof. We have given only numbers. Go back to the discussion room. Start with, okay. See, here we have changed the proof, digressed. Now we have to prove. We have to prove Xing here. So there are two cases. One is Q is positive. If Q is positive, in that case, tell me what is A, what is B. If Q is negative, again you have to say what is A, what is B. In terms of P and Q only. Okay. Do this exercise. Tomorrow you should be ready. Okay. I'll stop here because I don't want to extend more than 5 minutes. We'll stop. Go through this. Okay. We'll start from this question on next class. Yeah. Bala, Divya, it's over.
Yes, sir. Thank you, sir. So thank you, YouTube participants. We'll meet on 27 October.